we're going to go through today is a demonstration of a pipeline that we use internally for managing our cloud environments. What we're going to actually build is a small little web app running on Elastic Container Service in AWS. Right now, Carl, can you go to like the endpoint in the browser? Just want to show it's not running. And there it is, it's dead. You can see it, it's not running. What we're actually going to do is we're going to build this live. We're going to have the process fail first because like the rules that Josh showed, we're going to not meet one of them. And then we're going to basically remove that rule and have it succeed and talk about some other integrations. And really the theme here is that the OPA policy checking engine that Josh has talked about, we're going to show how it can be wired up into an infrastructure deployment pipeline, as well as some sort of addition things that we'll talk about. So, Carl, let's go to the repo and the look at the rules. So, can you kind of summarize these rules real quick? These are what we're going to be using to demonstrate.
Yeah. So for today's demo, so we're actually using the OPA binary, but we're using the regular rules and libraries that they use to
write the rules in.
Yeah, execute the rules. So these are the three rules that we're going to be implementing. It's making sure that for EC2 instances that you only have sizes T2 small to T2 extra large, if you're familiar with EC2 instance types. We're going to be ensuring that all resources are tagged, and we're going to be ensuring that all the resources are deployed in the US East 1 region.
And like, thanks, Carl. And like what Josh said is, you can write any policy as long as it's checkable or able to be tested against your IAC script, or whether it's Terraform or Azure ARM or CloudFormation. You could write anything, very simple to complex. But Carl, let's dive into the tag one, because this is the one we're actually going to fail on. So let's open up the tag. Go back to the repo real quick.
Oh, sorry about that.
Yeah, that's okay. So let's open that up. And what this says, and you can see it's very sort of easy to read through. I'm not a developer, but it's saying that for these type of resource types, and you see there's a list there. Of course, all this is editable. You have to have at least one tag, and it has to be at least 6 characters. That's what this rule says. Tagging is especially for development, high turnover environments. Tagging we found to be very important for tracking orphan resources, making sure stuff doesn't live in that we don't know about, that can lead to additional cost or to security threats. So yeah, let's jump into it. So so what we're actually going to show today is we're using AWS Code Pipeline, which is AWS's hosted CI environment. You could just as easily do this in Jenkins or Circle or Azure DevOps, or you could bash it all out. So we're going to use AWS Code Pipeline to run the demo. So Carl, let's jump into it. And this is yeah, let's dive. So before you click anything, these are the steps, and they're called code build projects. What's nice about Code Pipeline and Code Build is this is all ephemeral, meaning this only the little containers that are used to do this work here, they only get fired up at runtime. So it's a very low cost, a few bucks a month, as opposed to having running a server full time, running Jenkins or something. So let's go ahead and hit release, Carl, and release here just means run, right? And what should happen once this fires up is our Terraform script, which is in GitHub, gets accessed. It gets converted to JSON and then passed to OPA. So as long as you can convert something to JSON, OPA can read it. It just has to be JSON. And then let's go to the tail of the step we're in. I think it's the OPA check step. Tail, this is just the sort of console output if you had a shell up. And what we'll eventually see here is that this is going to fail because it's going to include the tag requirement check, and it will fail because we have some resources as part of this demo app that don't have tags. So actually what it's doing live is, see, it's downloading the Terraform binary. We have to download Terraform this step in order to output our plan event as JSON. And I think we failed. So yeah, so there in the red text at the bottom is the general fail message. And like Josh said, you can write the rigidness of your policy checks, whether they're sort of pass fail like we have here. You can do sort of an additive score. So maybe, you know, you have to hit a score of whatever amount you come up with to fail, or maybe you pass everything, but you give warnings to developers. But Carl, can you kind of summarize the output and show where we failed?
Yeah, so as we stated earlier, we're executing 3 rules, and 2 of them passed, as you can see in at the bottom in the summary, and 1 failed, and the one that failed is the tagged resources one. So if we go up here to the tag resources rule, we can see that most of them failed. We do have some resources that were tagged, but the vast majority failed. So the whole rule failed.
So now what we're going to do is we're going to open what's called a build spec file. This is basically a configuration script. This is where we point to the regular repo. I should say, let me pause here and make a statement. We built this pipeline before regular came out, and we were using native OPA policies. What the regular, and you don't have to use regular to make this work, but where it provides a big advantage, really, in my opinion, is twofold. The Fugue has simplified, they've sort of wrapped the OPA rules with some helper scripts that make writing the actual policies easier than writing sort of native Rego. And also what's been great, what they're doing is they are releasing rules that tie back to control sets like CIS or maybe NIST. So, you know, if you're in an environment where you maybe have to be NIST 853 compliant, this allows you to check things and tie them back to the work that was done to figure out, hey, this rule, this control, how do I actually write that as a policy? A lot of that's being done, and you know, we're going to contribute back to this. And as they release more, these libraries just become more robust and more feature filled. So let me pause here, and Carl, can you show where that rule was, and we're just going to comment it out.
Yeah, so I went through the liberty of already commenting out the old rule and uncommenting the rule that we're going to be using. So basically, this OPA eval is the command that you use to evaluate your Terraform JSON plan against certain either libraries or rules. And so we're using Regular's library, which supports the rule execution. And these 3 rules, as you can see in the old command, are pointed out right here. And then in the new command, we just are not using the tag resources rule.
Yeah, we just removed that. And what's nice about it is we can point to whole directories on the regular repo, or we can call out, as we do here, the individual file. So it's easy to add and remove the different rules. So okay, so let's go ahead and rerun the process with that rule removed. And what we hope to have happen, fingers crossed, is that it runs successfully. It'll build the infrastructure, it'll pass the rule, and then eventually we'll show you something that's running.
So to save a little bit of time, I'm just going to retry the step that actually failed, the OPA check. And as soon as it starts, we can go to the console output.
Yeah, it takes a few seconds for it to fire up because, again, this stuff is ephemeral. So, you know, the plus side is you could speed things up if we baked like Docker images that already had the binaries on them. The whole process takes about 5 minutes, so it's not too big of a deal. But what we really like is there's really no existing infrastructure, so we keep our costs down. And what we should see here in a moment is the final output of the OPA check, where it has parsed our Terraform script against the regular rules, the OPA rules that we're using, and it will pass. There you go. Awesome. And then, so what's happened now, yeah, if we go back to the page above that, is with this step done, it's now going to move on to the actual deployment step. So this is the Terraform apply, the verb apply, in Terraform world means it's actually running it and deploying it. So let's go ahead and look at that tail.
Hey, Dave, while the build is happening, just thank you for bringing up the fact that with Regula and OPA, you can use these OPA rules at the step we're showing you now, right? You can use them for checking your source code at the plan stage, but with Fugue, and Fugue has a free developer version that's free forever, you can actually use that same code. And Fugue, this is what we do for a living, is policy and security and compliance and all that stuff, cloud security for engineers, for developers and engineers, by developers and engineers. That same policy that you're using to check your Terraform plan that we're showing you here can then be used to monitor the production environments. But it looks like we just got some progress. So I'll turn it back over to you.
Yeah, you're exactly right. So the way I think about it, and I have a graphic here in a sec, but actually let me talk to what's on the screen. So what's happening now, if you look at the line items, these are actual resources being deployed. So this is a full stack. It's got a VPC, it's got subnets and a load balancer. So we're doing all this live. And as Josh said, I've been working for a while, since long enough, where I used to rack servers and run cable and patch panels. And he's right, it would take months. And now we're doing this. We're going to build this entire thing in a few moments because it's scripted. Again, that consolidates risk. Josh used the term sort of, there's less friction. I think about it like this. When I did this in the data center, we'd have probably 30 folks over a several month process look at design. Now, most of the clients we work with, there's 1 or 2, 3 core dev ops engineers. You've put all the risk on their shoulders. And to try and manage that manually just is not feasible. And that's why we believe this preventative policy checking combined with a as deployed checking is really important. And on that note, while this is running, it's going to take a few moments to build because it's got a load balancer. Let's go ahead and pull up, Carl, the graphic. I've got a little simple graphic that just illustrates can you kind of maximize that if possible? Okay, it's on the middle screen. So working left to right, what is going on is on the far left, we have source control. You can use any source, right? This is the GitHub icon, I think. We're using GitHub. It's very popular in this example, but it could be any source control. It could be a local file. The first step is with the OPA helmet. I think that's like a Viking helmet, maybe. We're parsing our source control document, our infrastructure as code document. It could be anything. It could be ARM template. It could be something like Ansible. It could be Terraform. It could be CloudFormation. It could be your AWS CDK that you've distilled down to CloudFormation. If you can JSON it, you can check it. We're proactively checking that against our rules. And what happens is on the Terraform step, as we saw, if it fails, if it doesn't pass, you can kill the process. You can just alert. You have lots of, but it's an upstream catch. The Terraform box in the middle, again, could be any IAC tool, but the key here is you have to commit to infrastructure as code in order to check it, right? It then deploys. We go into, and here we have AWS and Azure. Of course, if you're using Terraform, it literally supports anything I probably will ever touch in my career. GCP and Alibaba and OpenStack and hundreds of providers. Now, one of the things that's a little bit I want to call out here is, now once we have our infrastructure deployed, as Josh said, and as probably everyone on the call knows, people are going to use the console, right? The UI. It's called Azure Portal. It's called the AWS Console. If they make changes out of band or out of this process, how do we check? And that's where we use Fugue. So Fugue monitors our environments, and it actively monitors them against a known baseline, right? So once we deploy, we say this is what this environment should look like. If someone went in and changed a port opening or made an S3 bucket public, Fugue tells us, and they can also self-correct that. So what we're going to show at the end of this is we're going to show how Fugue ties in, and this entire pipeline is automated. And that's one thing I want to stress here is this is all automated. So and the reason this is important is the Fugue piece, if we didn't coordinate with Fugue, what would happen is it would see our change as drift and potentially roll it back. So we have to basically stop our drift detection, do our deployment, and then tell our drift detector, Fugue here, that, hey, this is valid. So then it can then use that as the updated baseline. So let's go ahead and close this, Carl. And I think we should be getting close to being done. Okay, it's still running. So while this is running, we're near the end though. It's creating a DNS record. Let's go ahead and pull up I just want to show the Fugue UI, just to show what the old baseline was. So can you kind of point to the baseline? Yeah, the time right there. Yeah. So what this is saying is the last time this was run, and again, the baseline is the desired image, like sort of an image or a state of your environment, your AWS or Azure. It's saying the last time this was updated was yesterday around 2:12. And the reason I'm pointing that out is when this pipeline build is done, you're going to see this time updated. So let's jump back to the output. and we should be getting there. So,
Yep.
okay, so
now Fugue is running and scanning.
So yeah, so what's happened now, and I just happen to know this because I know I know it's a sort of hard to read, but what's happened is all our infrastructure is built, and now we are instructing the Fugue API to update and create a new baseline. So while this is running, this takes about a minute. Let's go ahead and look and see if the app is up. See, it takes a few seconds for the DNS to propagate, but if we hit the thing, it might be ready. There it is. Okay. Okay, so now it works. So I know this is sort of the tip of the iceberg in that this is just a little simple screen, but under it is an ECS container, networks, and load balancers. So cool. So this real working stuff works. This happens to be some dummy data that we use for demos. And now if we go back to the output.
Still scanning.
It's scanning, yeah. Should be done pretty soon.
So like you know, Dave was saying, you know, this caters to, you know, the whole software development lifecycle, and if you want, you can put unit tests. You can implement unit tests in this pipeline. Some other software development checks that you would like. You know, it's configurable to, you know, anything you want to do really. It's just a framework. Get you started in terms of being specific for your organization.